Hello everyone, this is Siyashi Sahu with my teammate Yotshi Jen, and today we are going to present about Kruskal's algorithm for finding the minimum spanning trees. So before going into Kruskal's algorithm, we should first understand that what is spanning trees and minimum spanning trees. A spanning tree is a subgraph of an undirected connected graph which includes all the vertices of the graph with a minimum possible number of edges. If a vertex is missed, then it is not a spanning tree. The edges may or may not have weights to them. One important point that we should keep in our mind is that we can take only those edges in the spanning tree which are already present in the graph. Minimum spanning tree. A minimum spanning tree is a spanning tree in which the sum of the weight of the edges is as minimum as possible. For a minimum spanning tree, the graph should be weighted so that we can calculate the sum of the weight of edges. Let the graph is this one whose vertices are A, B, C and D and weight of edges are 4, 1, 2 and 5 respectively. Then the possible spanning trees of the given graph is this 4. In first spanning tree, B is not directly connected to C, but we can reach B from B to C via A and D. Similarly, these are others. The sum of first spanning tree is 4 plus 5 plus 2 which is 11, and the sum of weight of edges of second, third and fourth spanning tree is 8, 10 and 7 respectively. And from here we can see that the spanning tree with minimum sum is the fourth one whose sum is 7. So the minimum spanning tree from the above spanning trees is this one which is having lowest sum of weight which is equals to 7. Also, one more point, there can be more than one minimum spanning trees for a graph if the graph has any edges whose weights are same. The minimum spanning trees from a graph can be found using the following two algorithms. First, Kruskal's algorithm. Second, Prim's algorithm. And today we are going to learn about Kruskal's algorithm.
Kruskal's algorithm. Kruskal's algorithm is a minimum spanning tree algorithm that takes a graph as input and aims to find a subset of the edge that form a tree that includes every vertex with minimum edges and has the minimum sum of weights among all the trees that can be formed from the graph. Now let us see that how it works. We'll be given with a graph and we have to sort all the edges from low weight to high and take the edges with the lowest weight and add it to the spanning tree. If adding the edge created a cycle, then reject that edge and keep adding edges until we reach all vertices. This can be understood through an example. Let us see a weighted graph in step number 1 whose vertices are A, B, C, D, E and F respectively. We have to remove all the loops and parallel edges firstly and choose the edge with the least weight, that is AB and BC. We can choose any one of them. Let us take AB. After that, we have to choose the next shortest edge and add it, that is BC. And then we have the next shortest edge, that is BF, FD and CD. We have chosen BF at random and making sure that it does not create any cycle. After that, we are left with CD and FD. So let us take CD. Now we have DF as the shortest edge, but we cannot add. Why? Because it will create a cycle and we have no requirement of cycle. So we have to reject that particular edge. Now we have the shortest edge as AE, BE and BD. But we are not going to take BD because again it will create a cycle and therefore we have to reject that BD. So now we have AE and BE as an option, so we are choosing BE. This is in step number 6 we can see that, and this is how our spanning tree is completed. Also I have to mention one more thing, that Kruskal's algorithm is also called as greedy algorithm, as in each step it adds the next lowest weight that will not form a cycle to minimum spanning tree. Thank you for watching, and if any queries, do comment.